let's talk about what we might call modern JavaScript. As we know, JavaScript has a long history, and we're now living in a time where tools have advanced to a point where writing JavaScript applications becomes so much more productive and efficient with the addition of proper tooling. Tools save us lots of time, they help catch our mistakes and help automate many tasks. So here are some of the things that we want to automate and use tasks for that are going to make our development environment far easier. First up is package management or dependency management. A typical JavaScript project has more than one dependency, and dependencies are typically code projects that we would like to include. You can think of these as things such as date pickers or libraries that make our programming lives easier. There are millions of JavaScript projects that exist in the open source community, and instead of reinventing the wheel each time when it comes to common JavaScript components and libraries, we can simply install those that we'd like to use to make our lives far easier and get started with our real development much quicker. These projects are typically called packages or modules and are published by developers from all around the world. A package manager does simply what it says. It helps us manage the packages that we want to use in our project. Next, we would like to have some kind of real-world development server that serves us our project locally. This will later include things such as live reload, compilation on the fly when we save a file, and much more. Having a proper server allows us to develop real applications that can make HTTP requests to a backend as well. Another task that we'd like some help with is the automatic transformation of ES2015 or ES6 code down to ES5, and we've looked at this in the previous lesson. It wouldn't be a good use of our time to keep manually converting ES2015 code to ES5, which is why we're going to adopt Babel in our workflow to act as our compiler, or sometimes called a transpiler. Anytime that we save a file, Babel will then transform our code back to ES5 every single time, and we don't have to do this ourselves. In JavaScript, the order of execution and initialization does indeed matter, as we need to make sure that any variables that we reference are in fact defined at that point in time. Otherwise, errors are going to be thrown. This introduces the complex task of module management, which we're going to make super easy with something that we call Webpack, to a point where we're going to set it up once and we no longer need to worry about it. Webpack is a module bundler that combines our JavaScript together if and when we need multiple dependencies. So as our project scales, everything is taken care of, and we can focus on building out the project rather than trying to manage how we might scale it. Dependencies could consist of things such as date pickers, a favorite image slider that we might want to include, or in fact a utility library of functions that make our programming lives easier. Think of them as individual units that we want to make sure are included in our project when we deploy our application. So essentially we need to bundle them all together. Webpack allows us to put all of these dependencies into a single file without doing any extra work on our end. It also handles more advanced techniques such as code splitting for lazy loading. Finally, we need to introduce something we call linting. Linting is essentially analyzing our code on the fly to pick up any potential errors. Typically, when we install a linter, we will be given warnings or errors in a terminal window, or you may see our familiar red squiggly line if we've done something wrong. So here are the tools we're introducing today that help us in doing all of these things. We have Node.js, npm, Babel, Webpack, and finally ESLint. Let's jump in and find a little bit more about each of them by showing you the bigger picture of how they all link together. Let's begin with Node.js. Node.js is going to help us run our local development setup. As we know, Node.js allows us to write JavaScript outside of the browser, which means that we can run it on our local machine, such as a laptop or any desktop computer. Once we've installed Node.js, that means it's now accessible through the command line or the terminal. With Node.js ships something called npm, the package manager that we'd like to use for Node. Before we can manage any packages, however, we must in fact tell npm what packages we'd like to install in this project. For this, we need something called a package.json, which lists our packages and the package versions that we'd also like to install. Now, to create a package.json, all we need to do is simply run npm init when we start a new project. We can then run an npm install command and provide any package names we'd like as the arguments to this command. This will then download the packages from npm's registry and save the names and their versions in our package.json. All of these packages exist as open source projects and are published as versions to npm so that we can go ahead and download specific releases. This means that if someone else downloads our project and runs the same npm install, they'll also be given the identical packages and versions. The package.json is something that we would also check in to version control, such as Git. So for instance, other developers on our team can join our project and get set up within just a few seconds. Once npm has finished downloading our packages, it then creates a new folder inside our project. This folder is then called our node_modules. So this is where all of our packages exist. This means that Webpack, Babel, ESLint, and any other packages that we'd like to include are now available locally in our project. Our project at this point would be ready to take on all of the tasks that we outlined at the beginning of this video, and we'll walk through these as we continue through the course because we are using this identical setup in our own starter project. So you'll be dealing with Webpack, Babel, and ESLint as we continue. If you're new to all of this workflow tooling, it does sound and look more complex than it actually is. Once we've completed the project setup and the walkthrough, you'll be really familiar with it in no time. I'd also recommend you revisit this video later on in the course as a refresher if you are new to some of these concepts. Now, we're not going to dive in too deep about how Webpack, Babel, and ESLint work. We're here to let them work for us and trust that they're going to do the right job. And that's where our modern JavaScript journey begins. We now have covered all the major components to get in the right tools and the environment set up, and now we can use them to get started with any new project. Check out the next lesson, which will also include some further reading links on all of these above topics, so you can learn more about them in a lot more detail in your own time. The setup, however, that we're going to use is more than enough to get us started in learning our modern JavaScript. So let's go ahead and continue with the course.